All right, welcome back to Calculus. We are finishing up our test 2 walkthrough kind of problems. So the first one says differentiate and simplify the hyperbolic tangent of the natural log of v. Okay, so that's always fun. So the important thing here is when it says differentiate and simplify. So you don't have to do them in that order. So what I would do is like, well, when you've got a hyperbolic function with natural logs in it, it might be worthwhile to investigate how's that going to look. Okay, so we have y is equal to the tangent, hyperbolic tangent of what we have here. We have ln of v. Okay, well, what's the hyperbolic function? What's the hyperbolic tangent looks like? Well, it's hyperbolic sine um, over the hyperbolic cosine. Okay, so that's going to be hyperbolic sine. That's e to the x minus e to the minus x all over 2. And then hyperbolic cosine is e to the x plus e to the minus x all over 2. Go ahead and simplify this out. We're going to have e to the x minus e to the minus x all over e to the x plus e to the minus x. And what's the argument we actually want to use? We want to use the natural log of v. So we have e to the ln v minus e to the negative ln v divided by e to the ln v plus e to the negative ln v. So you have to be a little bit careful, especially with this negatives up here. Okay, this is going to be e to the ln v minus e to the ln v to the negative 1 using a rule of logarithms. Okay, and there's a reason I would like to do it that way is because if I don't, I'm likely to get this negative sign mixed up with a different negative sign, and I don't want to do that. We have e to the ln v plus e to the ln of v to the negative 1. Again, same logarithm rule. And then we're going to use that e to the ln of something is something. So that's going to be v minus 1 over v divided by v plus 1 over v. And now we have a compound fraction here. So going back to our intermediate algebra, or any other way you'd like to do this, I'm just going to multiply by v over v. Okay, and that'll clear my denominators out. So we'll get y is equal to v squared minus 1 over v squared plus 1. Now, this looks like a derivative that I'd be willing to take. Okay, so we have y prime equals, well, the derivative of the top, v squared minus 1, derivative times the second, v squared plus 1, minus the top, v squared minus 1, times the derivative of the bottom, v squared plus 1, tick, all divided by v squared plus 1 squared. Okay. And then what are we going to have here? We're going to have derivative of the top. That's going to be 2v, right? 2v times v squared plus 1, okay, minus v squared minus 1 times, again, derivative of v squared plus 1 is going to be 2v. And this is all divided by v squared plus 1 squared. Okay, I bet we could do something with this. This is going to be 2v cubed plus 2v. And we'll say this is going to be minus 2v cubed minus plus 2v, all divided by v squared plus 1 squared. 2v cubed minus 2v cubed, that's going to be 0. We have 2v plus 2v, that's going to give us 4v over v squared plus 1 squared, and that is a simplified form. And that's how we have it. So when you see hyperbolic functions, especially if there's logarithms inside of them, it's always going to be a good idea to see what's going on with that before you jump right in and decide to start taking derivatives, because you're going to be left with a mess, okay, especially if it says simplify. Whereas if you go in, maybe simplify first and then take a derivative, it's usually a much easier process for you. So let's see, what's my next one? So the next one is differentiate and simplify. Y equals x to the 5x. Okay, always a fun one. So we have y equals x to the 5x. Oh, when you have a variable in the exponent, the first thing you want to think when you have variables in the exponent is take logarithms. So I want the ln of y is equal to the ln of x to the 5x. Now this is not a calculus thing, this is a logarithm thing. So we're going to have ln of y is equal to 5x times ln of x. Now I'm interested in taking derivative. So we're going to say this is 1 over y times dy, because you got to do implicit differentiation here, equals, and notice this is a product. So we have derivative of the first times the second, plus the first times the derivative of the second. And it's just a product rule, we don't have to worry about anything else. Okay, so this is going to be 1 over y dy, and then derivative of 5x is simply 5 times ln x plus 5x, okay? And then we have 1 over x for the derivative of natural log. So simplify this a little bit. We have 1 over y dy is equal to 5. I'll pull 5 out of both terms here. And I've got ln x plus 1, because I've pulled the 5 out, okay? And then what do we have next? We have to multiply by y. So we have dy by dx is equal to y times 5 ln x plus 1, which of course is 5 equals, or y equals 5, and we have times y. What was y? That was x to the 5x. So it looks like we have 5 x to the 5x times the natural log of x plus y. Beautiful. And that's simplified form. Okay, so just hit simplify in there because I don't want you guys to just take 1 over y dy equals this stuff and then be done with it at that point. Now you got to do me a favor, simplify it out there for me. But that's it for that one. Okay, so hopefully it doesn't look too bad for you. Okay, let's see the next one. Logarithm problems are always fun. Y equals natural log of 3u plus 2, 3u minus 2. And simplify. So we have y equals ln of the square root of 3u, what was it, plus 2, 3u minus 2. Whole square root on one side of this. So again, we're going to use some rules of logarithms. Okay, this square root is really to the 1/2 power. So this is going to be y equals ln of 3u plus 2, 3u minus 2, all raised to the 1/2 power. This is going to come down in front. Again, this is a logarithm rule, not a calculus rule. So we have y is equal to 1/2 times the ln of 3u plus 2, 3u minus 2. Now, I know as much as you guys are really dying to go through and do another quotient rule, I can hear you from here. Oh, we don't get the quotient rule? Not in this case. So what you want to do is you want to say, hey, there's another rule of logarithms. We're going to say this is y, that's a terrible y, equals 1/2 natural log. It's inside the logarithm, so this is going to be 3u plus 2 minus, we'll put a big bracket up here, ln of 3u minus 2. Now, I think I'd like to take a derivative. So we have dy equals 1/2, and then we have, what's the derivative of a logarithm? It's 1 over 3u plus 2 times its chain minus 1 over 3u minus 2 times its chain. Notice there's a 3 common to both of these things, so we can go ahead and say dy is equal to 3/2. And then I've got 1 over 3u plus 2 minus 1 over 3u minus 2. And because this was such a nice problem, we'll go ahead and do me the favor of simplifying the terms. So this is going to be 3 over 2, and this is going to be 3u minus 2 over 3u plus 2, 3u minus 2, minus, and then we have a 3u plus 2 here, 3u plus 2, 3u minus 2, and we'll do some arithmetic here. Okay, this is still dy equals. Okay, so this is 3/2 dy equals, and I've got 3u minus 3u, that makes it 0. Okay, so these two are going to cancel. The common denominators are now the same. We have 3u plus 2. Don't have to multiply this out. Okay, and then we have minus 2 minus 2, so that's going to give me a minus 4. So one more simplification here. So we're going to have, these 2's are going to cancel. Okay, so this 2 and this 2, they're going to cancel. So we have dy is equal to minus 2 times 3 is 6 times 1 over 3u plus 2, 3u minus 2. Okay, and that looks to be about it. Put brackets in here, I guess, to make everything good, but you know, now it's perfect for my college algebra class to go ahead and graph that. Okay, so that's a good problem. All right, so let's see what the next one is. There it is. The next problem looks like number 10, differentiate and simplify. So instead of the natural log of a quotient, we have the natural log, we have the quotient of natural logs. Okay, so we have natural log, or y equals natural log of, so we have y equals ln, what do we have here? We have 2x plus 1 divided by the natural log of 3x minus 2. You don't know how much I really wanted to write this as the log base 3x minus 2 of 2x plus 1. Really wanted to do that. I have a feeling that that would pretty much end the problem for a lot of people right there, but we could have written it that way. But if you ever do see this, this is not a hint. Okay, if you ever do see this weird base, it's not a natural log, it's a base with some kind of weird thing here, you're going to have to use change base formula. Okay, but that is not a hint. I did not do this to you on the test. All right. So now we get to do a quotient wall because we have two functions with term dividing. So we have y tick equals, oh, it's derivative of the first, ln of 2x plus 1, tick times the bottom, ln of 3x minus 2, minus the top, ln 2x plus 1, times the derivative of the bottom, ln of 3x minus 2, all divided by the bottom squared. This is ln of 3x minus 2 squared. Now this 2 is on the outside of the logarithm. This doesn't get to come down in front. Okay, it has to be on the inside in order for it to come down. So on the outside, it doesn't get to do that. That's not a rule. Okay, so be careful about that. Y tick equals, well, what's the derivative of natural log of 2x minus 1? This is going to be 2 over 2x minus 1. It's 1 over the u times its chain. Okay, times ln of 3x minus 2. Okay, minus, and then we're going to have this one. So we have 1 over 3x minus 2 times its chain, which is 3. And we have times ln 2x plus 1, all divided by natural log of 3x minus 2 squared. I know I said simplify on this one, but actually after getting common denominators, nothing cancels. So I'm not going to have you waste the time to do that because nothing, you know, we got to multiply by things, and then this natural log is different than that natural log. So nothing is going to be able to combine, nothing's going to cancel. We're just kind of stuck with the way it is. So we're just going to wrap it up in one big gift and say, okay, there's your answer. And there's not much more we can really want to do with this thing. Okay, so I hope that the test prep for this one was helpful to everybody. The logarithm problems tend to be a little bit tricky, but if you see the trick, then they tend to be kind of easy. So just remember that don't fear the logarithms. Okay, just embrace them. Remember all of your logarithm rules, and then try to utilize them before you have to run in. Don't wildly start taking derivatives. Just make like sure. Hey, do we make sure that everything is a simplified form as we can first before you start taking derivatives and make a mess? Okay, I'll leave you with that. I wish you the best of luck studying for this test, and I hope everybody does great. Thank you.